Hello, and my name is Toni, and I'm your FSHN101 instructor, and today we're going to be discussing breads. And I want to tell you a little bit about the history of breads. So we found out that over 14,000 years ago, breads were made. We find remnants of prehistoric bread in Jordan. And this predates the advent of agriculture, and you may think, oh, that's not a big deal to predate agriculture, but think about the fact this predates agriculture by 4,000 years, which means that you have individuals wandering through the forest finding wild grains, kind of in a hunter-gatherer group. So it would require a lot more effort than what you might think of today. So they would have had to really be dedicated to that loaf of bread in order to go and gather all those grains, grind them, and then make the bread themselves. So while it would not have been a staple of these people's daily food life because it would have required a lot of effort, evidence of cooking before agriculture is still very interesting to discuss. And so we're going to be discussing that in this module as well as future modules. So a little more history. About 3000 BC, ancient Egyptians used yeast to make fermented breads. And so when we start thinking about fermented breads, we're going to be discussing some wild yeast in some of our future slides here and talk about how you can even make your own bread from wild yeast. So willing costs caused whole wheat and whole grain bread to be very popular because separating out that husk from the grain itself was really difficult back then. However, beginning in the 1900s, white bread became way more popular and extremely common comparatively because of the fact that, again, you can remove the husk a lot more easily and people like the fluffy texture of that white bread. However, today the trend is flipped, and this is because we're learning more and more information about health concerns surrounding a lot of white bread consumption comparatively to some health benefits associated with consuming whole wheat or whole grain bread. So whole wheat bread is becoming the most nutritious, most popular because of the fact that we're keeping all parts of that wheat kernel in that particular bread itself. So let's start by talking about white bread. White bread has some very simple ingredients. The main ingredient is enriched wheat flour. And you may think this is a fabulous thing because if it's enriched, that means vitamins and minerals are added into it. But what you may not realize is the reason that vitamins and minerals are added into enriched flour is because it has been processed. We've had some chemical treatment, some heat treatment, things possibly removed from it that take away some of its nutritional value. And so what we do is we enrich it back in, and then we make bread with it. So even though you may think enriched is good, it just means that it's processed. It's not good or bad necessarily. It just means that it's gone through different steps. We also have water, salt, and yeast. So like I said, bread is very simple in its ingredients. White bread does not contain bran though, and because of this, it lacks the ferulic acid, which in turn makes the white bread taste very light, very airy. It's not as dense as the whole wheat bread that you might be used to. The texture of white bread is fluffy and soft, and it has a semi-sweet, bland taste to it. And the longer you have the white bread in your mouth and you chew it, the sweeter the taste actually becomes because the salivary amylase in your mouth will start breaking down those complex carbohydrates that have been processed into that white flour, and therefore it's going to start releasing breakdown products like maltose and glucose, making it extremely sweet. And a recent study says the crust of the white bread can smell like corn chips, potatoes, caramel, and flowers. And if you have homemade white bread, the smell has been described as similar to alcohol. And this is because of the yeast fermentation that is placed as that white bread is being made. And if you compare it to whole wheat bread is made using flour that is almost entirely milled from whole wheat grains. So with that in mind, it's made from the red wheat, which gives it its dark color. It has the bran inside of it. And because it has the bran, it has that ferulic acid, which gives it that more natural taste and, again, a denser bread itself. And a recent study done shows that whole wheat bread has a malty, earthy smell with hints of cucumber. It has a complex dent, slightly bitter and nutty taste to it because of the use of the entire kernel. And very little gluten is in whole wheat flour comparatively to the white flour, which causes the whole wheat bread to feel very dense. If we're looking at sourdough bread contains higher levels of vitamins, minerals, and antioxidants compared to some other breads. And this is because of its processing technique, which we will discuss. Its taste is similar to yeasted breads, but it has this tanginess because of the natural acids. A sourdough starter, which we're going to talk about how to make, contains lactic acid in it, bacteria, and wild yeast, which gives this bread its slightly sour flavor. And sourdough bread smells sweet and fresh like a yeasty bread, but has, again, some sour notes associated with it. And it often looks very crispy on the outside with a nice fluffy center. So let's see if you were paying attention. We'll do a testing your knowledge question. Which type of wheat is whole wheat bread made from? Is it white, red, brown, black, or yellow? And if you said red wheat, you are correct. So now let's discuss what we're going to do with regard to a sourdough starter. With a sourdough starter, it starts out with just some simple whole wheat flour and water. So what we're going to do is we're going to mix that half a cup of whole wheat flour and a quarter cup of water in a jar until it's smooth. The consistency should be thick and pasty. Cover it with plastic wrap or a lid and have it rest in a warm spot, like 75 to 80 degrees Fahrenheit for about 24 hours. On day 2, check for bubbles in the starter. These are signs that fermentation is happening. If there are no bubbles, it may also be because it kind of like dissolved overnight. So don't worry, rest for another 24 hours, watch it a little bit more. And just kind of a little hint here with regard to the starter itself, something that may be interesting is if you're wondering how you can get it that 75 to 80 degrees Fahrenheit, what you can do is you can actually take the starter, put it inside of a microwave with the door just barely shut so the light stays on, and then it's going to be that nice 75 to 80 degrees Fahrenheit without having to worry about it. Next, on day 3, remove and discard approximately half of the starter from the jar using a spoon. And you might say, why are we doing this? We'll talk about that later. But just know we're going to remove about half of that starter. We're going to add half a cup of all-purpose flour and quarter cup of warm water, and we're going to mix with the fork until it's smooth. The texture should resemble thick pancake batter. Let it rest for another 24 hours. You may also notice that there might be a dark liquid on the starter. This liquid is called hooch, and it indicates that the starter needs to be fed. If the hooch is present, it's best just to pour it off. On days 4 through 6, you're going to repeat the same process done on day 3. And on day 7, the sourdough starter is ready. It should have doubled in size with plenty of bubbles. The texture should be spongy and smell pleasant. What you want to do right now is transfer it to a nice, clean jar. Another tip and trick, if you want to put it in this jar, place a rubber band to measure the starter growth. So you can actually tape the rubber band to the edge of the jar itself, put little lines, and watch your starter grow and come to life. Next, what we're going to do to keep the starter alive is we're going to discard and use half the starter using a spoon. We're going to add equal parts of flour and water by weight. For example, if there's 60 grams of starter inside the jar, feed it with 60 grams of flour and 60 grams of water. So we want a 1:1:1 ratio. We're going to place it in that warm spot again and let it rise until bubbly and doubles in size. Another storage option, if we're going to have this starter for a long time, is we're going to take the starter and we can put it on the countertop, but you need to make sure that you're using it regularly and feeding it every day. If you're not going to be using it regularly, you can keep the starter in the refrigerator, and this is recommended if you're someone who wants to make it maybe, again, once a week or so. A tip or a trick, if you want to find out what's going on with your starter, you can drop 1 teaspoon of starter into a glass of water and see if it floats to the top. If it floats to the top, it is ready to use. So let's review the recipe. What is the science behind it? First, what causes the starter to ferment? Second, why start the starter using whole wheat flour instead of all-purpose flour? And third, why is half the dough discarded every time it is fed? Well, with the sourdough, it is an example of a food product using wild fermentation, which means that the fermentation is reliant on the microorganisms present in the ingredients that are there. So we have lactic acid bacteria and yeast that are found in the starter, and each starter contains a different type of lactic acid bacteria and yeast, which give the sourdough its unique flavor. So if you create a starter and your friend creates a starter, you will have different types of microorganisms in there. The next question, like we said, is why start it using whole wheat flour instead of all-purpose flour? Well, whole wheat flour contains way more nutrients as well as sourdough-friendly microorganisms. So it has a lot more tiny little bugs in it than all-purpose flour, which make for a lot more unique microbiota, giving that sourdough its characteristic flavor. Why is half the dough discarded every time it is fed? Well, discarding the doughs is going to allow us to refresh the acidity level and to control the starter's growth in size, because we don't want to have it overgrow its container nor remain too acidic. So with the sourdough bread, what we're going to be doing to make the bread itself is we're going to whisk the starter, water, and olive oil in a large bowl. We're going to add the flour and the salt, and you're going to mix it with your hands until the flour is absorbed into that dough itself. The dough will be a little dry and what we call shaggy. We want you to fill the bowl with plastic wrap and let it rest for 30 minutes or even up to an hour. After the dough has rested, work the dough in the bowl into a round ball, and it takes about 15 seconds for that to happen. And what you're going to do is cover the bowl with plastic wrap and leave it in a warm spot to rise for 3 to 12 hours. If your spot is a little cooler, it may take a little longer. If your spot is very warm, it may take less time. So keep that in mind and keep an eye on your dough. The dough is ready when it's doubled in size and no longer looks dense. And something to think about, the oldest sourdough starter is more than 4,500 years old. So we've been doing this for a long time. And if you're wanting to see a video of someone folding in the dough and making it into that ball, you can watch this video on your own through Canvas. Next, we're going to use the parchment paper to cover the bottom of the Dutch oven, and that prevents it from sticking. Place the dough inside and cover the lid for a second rise. This is about 30 minutes to 1 hour. While you're doing this, preheat your oven to 450 degrees. And something to kind of point out, that your dough can be cut using a bread lame or a small serrated steak knife to give that characteristic X, which you can watch on your own through Canvas with this video. Next, we're going to place the bread into the oven in the center rack. Keep the Dutch oven lid on, reduce the temperature to 400, and bake for 20 minutes. Then remove the lid and continue to bake for 40 minutes or until golden brown. Remove the bread from the oven and cool on a wire rack for at least an hour before slicing, and enjoy your delicious masterpiece. So let's review the recipe a little bit more. What is the science behind it? What's the importance of scoring the bread? And what happens to the dough when it is baked? Well, scoring the bread allows the steam to escape and for the dough to expand during baking. And when the dough is baked, we have these Maillard reactions. And these Maillard reactions are a chemical reaction between an amino acid and a reducing sugar. The reaction is what causes that classic brown on the outside of your bread itself. And so what I want to highlight is that, in case you didn't know it, your yeast is actually eating the bread before you get a chance to. Yeast are amazing. The yeast are going to have enzymes that are going to break the starch, which is in your bread, into maltose. And those enzymes are going to be amylase. So the yeast actually produce their own amylase to break down starch, or amylose, into its component parts. And because it doesn't cleave every single bond, sometimes it leaves these maltose units, or a disaccharide, where maltose is made of glucose and glucose bound together. So yeast are going to be making that maltose. And yeast can even break complex sugars like maltose or disaccharides into their component parts. So yeast also make maltase, which is an enzyme that's going to allow the maltose with 2 glucose units to be broken down to 2 glucoses by themselves, or those monosaccharide units. The yeast also can break protein chains. So we have enzymes that can cleave between those amino acids in those long protein chains. So let's look at this in a little more detail. We have digestive enzymes, but digestive enzymes are also inside those yeast. So the yeast amylase breaks the starch into maltase. And so if we want to look at this, you can see the amylose and amylopectin, which are going to be, again, long chains of glucose units linked together. And if we have the amylase, which is going to break down starch, or amylose, it's going to cleave wherever it's most convenient. Again, a lot of times leaving a maltose unit, or again, 2 glucose units linked together. But we want to reduce it even more. So what we want to do is we want to take that maltose, or two glucose units that are linked together, to their individual glucose units. And so maltase is used to release glucose, and then we can use that glucose for that Maillard reaction. But like we mentioned earlier, the Maillard reaction also requires amino acids from proteins. So the yeast has a carboxypeptidase, which cleaves peptide bonds in proteins. So here we have several amino acids linked together, and you can see that peptide bond in blue there. And with that, we can break the peptide bond, releasing those end amino acids so that they can react with that glucose and make that nice brown crust that you see on the bread itself. So with this Maillard reaction, if you're wanting to see it in action, here we have a raw potato. The raw potato has some breakdown products, like I said, those glucose, and then it also has individual amino acids. If we put it into the oven and we bake it, you can see that browning or Maillard reaction. Every single one of our breads, the white bread, the wheat bread, the sourdough bread, all are going to have that nice brown outside. All of them are going to be made from flours. However, depending upon what it is that we're going to be baking, the white bread, wheat bread, or sourdough bread, you're going to get a slice of bread that might be slightly different in flavor, in color, as well as nutritional composition. So what I want you to do is look at those nutrition facts panels and see if you can see any similarities or differences between them. I'll give you a moment. Well, any findings that you saw when you were looking at those different nutrition facts panels? You may have seen that white bread and wheat bread have more fat and fiber than sourdough bread. With the sourdough bread, there's almost no fat in that sourdough bread with the traditional recipe. Added sugar in bread can supply the yeast with food, and the yeast quickly consume the sugar to release carbon dioxide to make the bread rise. So realistically, we don't have a lot of sugar in any one of those slices of bread. Proteins in the bread are incomplete since they're low or lacking or one or more of the amino acids that we need to build cells. You may not be able to pick up on that in the nutrition facts panel that you just saw. However, I do want to let you know that this is one of the reasons why we put peanut butter on our bread. Or if we have bread, we might pair it with a bean soup. We want to have legumes and grains together in order to have a complete protein. So the bread itself does not have a complete protein, even though we may see protein on that nutrition facts panel. And if you're looking at these bread slices, surprisingly, the sourdough bread has the least calories. So let's look at generally the macronutrient breakdown or ratios of a slice of bread. If we have this general slice of bread or a couple slices of bread at 58 grams, you'll notice they have 154 calories. We have carbohydrates making up 75% of the overall calories. We have fat making up about 11% of the overall calories in, we'll say, a slice of white bread, where protein makes up about 14% of the overall calories. If we're going to consume bread, which a lot of us do, we have to break it down first. And things that might be unique to the digestion of these different types of bread. With white bread, it does have a lot of starch in that white bread. And with the starch, we've got digestion that starts in the mouth by salivary amylase. That amylase is going to break down that amylose or starch, like I said, into those maltose units. And then as it continues down, we don't have much digestion in the stomach chemically, but when we get into the small intestine, the pancreas is going to secrete pancreatic amylase, and that pancreatic amylase is going to continue to break down the amylose or the starch itself. And then in our small intestinal cells themselves, they produce maltase, which is going to break down maltose, which is that product of starch breakdown. Once we've broken down the starch and the maltose to its component building blocks, the glucose, we can absorb it into the bloodstream. With whole wheat bread and whole wheat flour, we have soluble and insoluble fibers that may or may not be present in as large a quantity with that white bread. Those soluble and insoluble fibers have a lot of benefits to the digestive system. One of those is to act as a prebiotic. And you may not have heard this term before, but a prebiotic helps promote intestinal health, and we'll discuss it more on the next slide. Our sourdough bread has high amounts of B vitamins, folate, and iron. We've got gut-friendly benefits like prebiotic qualities that may go above and beyond our whole wheat bread, and we're still doing research right now to find out why that may be. But we keep using this word prebiotic, and you might wonder what it is. So let's discuss what a prebiotic is. A prebiotic is a compound found in food that helps promote the growth of beneficial microorganisms. So more or less, you're feeding the bugs in your body. That's a good thing though. We want to consume plant fiber. We want to consume plant fiber for a variety of reasons. One is we've got positive metabolic effects for ourselves, but we also have a lowering of cholesterol, and these prebiotics are going to allow the microorganisms in your hindgut or in your large intestine to have some dinner, to have something to snack on, and to make sure that they are there happy and healthy, so you can live a symbiotic relationship with those healthy hindgut microflora. And sources of some prebiotics are bread, fruits and vegetables, pretty much anything that has fiber in it. A probiotic is those actual microorganisms. So we have live microorganisms that help promote a healthy gut flora. So these microbes are going to allow our intestines to be as healthy as they possibly can be. It reduces the risk of certain types of cancers. We see a link to decreased obesity and type 2 diabetes, and we even see immune support. So these are some amazing benefits to making sure we are living a healthy life with our microorganisms. Some sources of probiotics are things like kombucha, yogurt, kefir, things that are going to have these live bacteria in them. When we talk about bread, something that we might be able to claim is that the technique of sourdough leavening produces breads with a lower glycemic index. And in case you're unfamiliar with what a glycemic index is, it's the rise in blood sugar following a meal. So if you have someone in your family who's concerned about their blood sugar rising too quickly after the consumption of bread, well, they might want to consider having something like a small slice of sourdough bread and seeing how that may impact their blood glucose. And we're still learning more about why this is. However, scientists suggest that it has to do with the organic acids that are produced by the sourdough microbiota that may delay that gastric emptying or delay the time that it takes for your stomach to empty into the small intestine. So things move a little slower through the intestine itself, and you don't have as quick a spike in blood glucose. Per 100 grams, whole wheat bread has more sugar than some white bread, but it's really relatively inconsequential. So if you're looking at the nutrition facts panel, I wouldn't be overly concerned about it. And you keep hearing me discuss this whole wheat kernel, and you might wonder what it's composed of. So if we look at this picture of a whole wheat kernel, you can see the outside has bran, the inside has endosperm, and we also have germ in there as well. So when we're looking at this whole wheat kernel, you may notice that we have, again, a difference in composition when we're comparing that bran to the germ to the endosperm. And bread accounts for about half of the consumed carbohydrates in our diet. So what's going on with this wheat kernel and if we process it? Well, the wheat kernel itself provides macronutrients, like I said, like the carbohydrate, the protein, and the fat. It's a very good source of micronutrients as well, like vitamins and minerals, and we even have bioactive components. The wheat kernel, like we mentioned, has these three parts. We have the bran, which is this outermost layer, and if you're comparing it to the endosperm and the germ, it contains the most fiber. The endosperm itself is the starchy section on the inside, and this contains a lot of digestible, complex carbohydrates, such as starch. And then we have the germ, and if we're comparing the germ to the bran and endosperm, comparatively, it has a higher ratio of protein. But not everyone can enjoy a nice slice of bread. Individuals who have celiac disease may not be able to because they might be struggling with an autoimmune disorder that results in the inability to consume gluten. And you may not be familiar with gluten, but gluten is found in wheat, barley, rye, and we have this gliadin, which is the protein component of gluten. And this is what actually triggers an immune response. And so people actually have an immune response on themselves. So it's not the bread that is really the issue necessarily. It's a person's response to the bread, almost like if someone gets stung by a bee. Some people don't have much of a reaction. Other people have a very pronounced and strong reaction. And if someone has celiac disease, their immune response is to take, and we have these intestinal villi inside of our small intestine, and those intestinal villi kind of get attacked by our immune system. So they get shorter and shorter and shorter and shorter, which means that we have less and less and less absorptive area in our small intestine itself. And with less absorptive area, we have some negative consequences, such as abdominal pain, diarrhea, and weight loss, all associated with the inability to properly digest and absorb other food products because of our body's immune response to the protein that might be in some of these products. There are other gluten-related disorders or even bread-related disorders, such as non-celiac gluten sensitivity. And even though this is not immune-related, and nor does it result in an allergic reaction, this does result in the indigestion of gluten. So that people might have a problem digesting that gluten, which produces gas, abdominal pain, sometimes some diarrhea. And if people are noticing that they have this problem, this non-celiac gluten sensitivity, this can be alleviated by maintaining a low FODMAP diet, which we've talked about earlier in the semester. We also have individuals who have wheat allergies, and this is actually an immune response when someone's exposed to consuming the wheat. But it's not an autoimmune response like that celiac disease. This is merely an immune response where the immune system is trying to attack the wheat rather than the immune system attacking your own body like celiac disease. The symptoms of a wheat allergy are vomiting, hives, and potentially even anaphylaxis. And in case you don't know, anaphylaxis could even lead to death. So let's test your knowledge. Blank is an autoimmune disorder and blank is an allergic reaction. Is it gluten sensitivity and wheat allergy and celiac disease and wheat allergy, or celiac disease and gluten sensitivity? If you said that it's C or celiac disease and wheat allergy, you are correct. So let's talk about moisture content. With moisture content, the bread has a water activity ranging from 0.91 to 0.98. So it's a very high water activity. The moisture content is roughly 36%, and the water activity of the crust is very, very different than the inside of the bread itself. The water activity of the crust is ideally 0.1 to 0.2, significantly less than the water activity of the center itself. And this allows us to keep the inside of that dough nice and fresh and the outside nice and crunchy, almost like a cracker surrounding that dough inside. So in combination with baking temperature, this low water activity gives the crust that crunchier texture and also that darker color. And as a reminder, the color is a result of that Maillard reaction in the crust itself. Moisture content and water activity of bread increases during storage at room temperature, and we'll discuss that later on the semester as we investigate the science of it. This contributes to the short shelf life of bread, up to 1 week for commercial bread with some preservatives, and you can imagine this is a much shorter shelf life than something like crackers. With dough, there's this term that we can use called dough hydration, and hydration is the ratio of water to flour in the dough itself. So doughs with higher hydration levels tend to produce lighter breads with larger holes. So hydration can actually exceed 100%. And you may say, that seems very odd, but this is when there's just more water than flour in that bread dough itself. And it's often the case for high protein or whole grain flours that we're going to be adding in, again, a lot of that water in there. And if we're going to be comparing different doughs, like let's compare pretzel or bagels. The hydration or the dough hydration of a pretzel or a bagel is going to be much lower than something like a focaccia bread. So we can look at the hydration level, the dough texture, the crumb, and then you'll notice that there is a strong correlation between those. So if we want a very dense crumb, a firm dry dough, we're going to have lower dough hydration percentages versus if we want a sticky dough with an airy and large whole crumb, then we're going to have a higher hydration of that dough itself. With regard to storage and shelf life, commercial bread can last for 3 to 7 days at room temperature. It depends on the type of dough, it depends on how many preservatives it has, but bread without preservatives lasts even shorter at room temperature. Some common preservatives include these listed here. We've got calcium propionate, sodium benzoate, potassium sorbate, and sorbic acid. You'll notice that we again have things that are going to potentially change the pH of that bread itself. We also have things like lactic acid bacteria that you may find in something like a sourdough bread that produces natural anti-mold acids. If you refrigerate your bread, it can actually increase the shelf life of any type of bread by 3 to 5 days, so you can keep it even longer in there. And if you want to freeze your bread, it can last up to 6 months frozen. But it does change the texture and the quality if you put it in the refrigerator or in the freezer. And again, we'll discuss that later in the semester itself. If your bread is spoiling very quickly, it may be because you're keeping it on top of the microwave or the refrigerator, where it's going to be warmer up there, and it's more likely to spoil in warm, moist environments. So how do you know if your bread has gone bad? Most people can see that their bread has gone bad. For example, you can see mold on it. And if you're unfamiliar with what a mold is, they're spores that appear to be fuzzy. Sometimes they can be spots of green, black, or white, or even a combination of it. If your bread has a weird or unpleasant odor or a strange taste, I would encourage you, when in doubt, throw it out. And even though it may not be something that's causing a health issue, if you have a hard texture, I would say your bread has gone bad. If you try to serve that to someone and you've got this crunchy kind of stale bread, you might just want to throw that out and start over again if it's something that's not going to cause much enjoyment and you've got another option. So let's get back and continue to talk about the microbiota, or those tiny little microbes in bread itself. So white bread and whole wheat flour are going to contain some microbes in them. The grain that makes the flour is going to have things like Salmonella, E. coli in them. So this is one of the reasons why we say, maybe you shouldn't eat that raw cookie dough. Maybe you shouldn't have a bite of that raw bread dough because it's actually made to be baked before you consume it. Yeast is generally added to make the breads, and the most common strain of yeast is listed here. We also have commercially made yeast, and commercially made yeast can effectively process maltose a little bit faster than some of the natural yeast that we have. So it may produce a different flavor bread, a different profile within that bread itself. And a fun fact, consumption of white bread may lead to an increase in lactobacilli levels in our guts, and consumption of whole wheat bread increases bifidobacteria and lactobacilli. Something to think about. If we're looking at sourdough bread, this type of bread uses a starter like we had discussed before. The ingredients are merely flour and water in that starter itself, and each starter has its unique group of microbes that are present. It's hard to name all the microbes, and so we're not going to go through that long list. And depending upon the type of flour, the type of water, the geographic location, and the maintenance practices of the flour itself, and even of the starter, is going to have a different property as far as that microbiota. The most common microbe found in the starter is going to be that lactobacillus. There are 50 or more species that we can find, and we even can find 20 or more different species of yeast. And a fun fact, we've got 2 researchers at North Carolina State University that started the world's largest sourdough project. It examines the microbes in a participant sourdough starter. So you can bring in your sourdough starter and they can actually analyze it and find out what's going on with the microbes. Kind of cool. And another fun fact, a British baker celebrated her 65-year anniversary of her sourdough starter. That takes a lot of dedication. I might not even be dedicated enough to make a sourdough starter and keep it alive for 1 year. 65 years, imagine going on vacation and having someone take care of your starter during that time. So let's talk about the future of bread. We're going to see a diversification of bread. So instead of having that white bread or that wonder bread that people consumed in the 70s, 80s, and 90s, there's this increasing trend of whole wheat bread and breads using ancient grains. And these ancient grains are recognized as healthier than white bread. We also see the addition of fiber and proteins into the flour to produce a more nutrient-rich bread. And we have artisan and craft breads that appear to be more frequently on the shelves due to an incentive to try various types of breads and people wanting to be more exploratory with their meals themselves. We also have this bread across the world where we're using diverse and ancient grains such as quinoa, barley, millet, buckwheat, sorghum, spelt. And so we don't just have different wheats. We don't just have oats. We've got all these different grains which we're going to be including. And these breads across the world are characterized by the phrase, look to the past for the future of bread. So it sounds a little bit campy, but it actually sounds something like I might want to try. And so the future of bread lies in its past. If you're wanting to watch a video on this, I encourage you to go into the Learning Management System and watch the video that we highlight. With that, if you have any questions, don't hesitate to stop in my office hours or in the Virtual Tutoring Center. We're here to help you.